These are the notes for Algebra 2. We're dealing with factoring trinomials. This is day 1 of 2. Now, we need a brief introduction to the idea of factoring trinomials. Now, we did see before about multiplying binomials, and we saw the box method that we use for multiplying binomials. But we're going to take the process of multiplying binomials and we're going to use that because factoring trinomials is the exact same process in reverse. So for instance, let's just review really quickly how we multiply binomials such as x plus 8 times x plus 4 to get a trinomial answer. Now, I've set up my box. It's 4 squares inside a larger square. I have x plus 8 written across the top. That's my first binomial. I have x plus 4 written across the side. That's my second binomial. And I get the terms of my trinomial by multiplying out the thing to get stuff in these boxes. And once I get stuff in these boxes, I add it all together, and that gives me my trinomial. So let's give this a shot. I have x times x is x squared. X times 8 is 8x. X times 4 is 4x. And 8 times 4 is 32. So if I wanted to add all this together to get a trinomial, I would add all of my individual terms, x squared plus 8x plus 4x plus 32. And then of course, these two terms in the middle are like terms, so I can combine them. And I end up with x squared plus 12x plus 32. And that is the trinomial that comes from multiplying x plus 8 times x plus 4. Now we've done this before, and when we talk about factoring trinomials, we're looking at this idea backwards. So we would start with the trinomial x squared plus 12x plus 32 and want to end up with the factors x plus 8 times x plus 4. And let's see how that works. Now we're going to use the same set of numbers here, x squared plus 12x plus 32. That means we already know that the answer should be x plus 8 times x plus 4. But here's how we're going to get this done, and we're going to be relying very heavily on this box method to get started. So, comparing the worked out multiplication here with my empty box, I'm going to say I don't know what goes along the side. I don't know what's going along the top and what's going on along the side. I have an idea of what goes in the box because I know that in the first box I have x squared, and in the last box I have 32. I know that because that is the first term here and the last term there. And when I multiplied binomials, the first term didn't get added to anything, the last term didn't get added to anything. The ones in the middle, these two, did get added together. So the entire trick that's going on here is figuring out what goes in each of these two boxes. Once we can figure out what goes in each of these two boxes, we will be able to work out what our factors should be. Now, to work it out, there is a simple trick we can use. What we want to do is multiply the first term times the last term. So I have x squared times 32. That is 32 x squared. So, I have 32x squared. Now, what I want are the factors of 32x squared. That is, two things I can multiply together to get 32x squared, that when I add them together, give me 12x. So they multiply to give me 32x squared, but add to give me 12x. And we can do this by just figuring out what the factors of 32 are. I could do 1x, or I could just say x. I wouldn't say 1x, I'd say x and 32x. X and 32x would multiply together to give me 32x squared. But they would not add together to give me 12x. X plus 32x is 33x, so that's not going to work. That's no good. I could also have 2x and 16x. 2x times 16x is 32x squared. But again, if I add the two together, 2 plus 16 is 18, not 12. I could also multiply 4x and 8x. 4x times 8x is 32x squared. And 4x plus 8x is 12x. What that means is that these two have to be the terms that go in my box. So 4x has to be in the box and 8x has to be in the box. The other factors didn't add up to 12x, so they can't be in the box. Now, the next thing I do is I just put these terms in there. And it doesn't matter which one goes where. Put them both in. Okay. We know, of course, that we add these two together to get 12x. 8x plus 4x is 12x. And I know that these are factors of 32x, so this is what I've got to use. Now, my last step then is to figure out what goes along the top and the side. And the process for that calls back the greatest common factors idea that we had just a little bit earlier. That is, we look up and down on this column and we say, okay, what is the greatest common factor of x squared and 8x? And we look at that and we say, well, obviously it's x. Then we go, okay, what is the greatest common factor of x squared and 4x, going the first row here? And that is obviously also x. Then I can say, all right, what can I multiply x by to get 8x? And the answer is 8. 8 times x is 8x. What can I multiply x by to get 4x? The answer is 4, because x times 4 is 4x. That means my factors are x plus 4 and x plus 8, which I knew to be true because we had multiplied this out earlier and gotten x squared plus 12x plus 32. But this time we worked backwards and we got the factors. Now let's look at one that we didn't previously get the factors for. I have 2y squared minus 7y plus 6. Now again, we're going to follow the same basic process. The first term is going to go in the top left box, so 2y squared will go in the top left box. The last term will go in the bottom box, 6. And we knew that because whenever we multiplied out, the first term never changed and the last term never changed. They were just what was exactly in the box. We need to figure out what goes in the other two squares, though. So we multiply the first term and the last term together. 2y squared times 6 is 12y squared. I want the factors of 12y squared multiplied to give me 12y squared that add up to negative 7y. So I look at these numbers, I say, okay, well, I have y and 12y. Now, since we're going to add up to negative 7y, and since this is positive, that means they would both have to be negative. Otherwise, it wouldn't work. All right, we can't add up and get a negative unless we have negative signs. But negative y and negative 12y make negative 13y, so that doesn't work. We could have negative 2y and 6y, negative 6y, and while negative 2y times negative 6y is 12y squared, negative 2 and negative 6 don't add up to negative 7, so this one is also not going to work. The last possibility is negative 3y and negative 4y. Again, negative 3y times negative 4y is 12y squared. And negative 3 plus negative 4 is negative 7. So these must be the factors that I'm interested in. That means they're going to go in the box. And I just write them in. Again, it doesn't matter which one I put where. I just put them in the box wherever I feel like. All right, I'm ready for that last step. I look at my column here, my first column, and I say, okay, what are my common factors between 2y squared and negative 4y? The answer to that would be 2y, because they both share 2y. I look at my first row, and I say, okay, what's the common factor of 2y squared and negative 3y? So the answer to that is y. Right? They don't share, 2 and 3 don't have any common factors. I have a y squared here and a y. That means that y is my greatest common factor. Now, to get 2y to become negative 4y, I'd have to multiply it by negative 2. Negative 2 times 2y is negative 4y. To get y to become negative 3y, I have to multiply it by negative 3. Negative 3 times y is negative 3y. That means my factors are 2y minus 3 up here and y minus 2. And when I write these, I do want to write them as two binomials being multiplied together. That's the way the answer should be represented. All right, let's move on. We have another one here. This time it's s squared plus 2s minus 48. And again, we're going to set this up. The first term goes in the first box because when we multiplied it out, it didn't change. The last term goes in the last box for the same reason. And we need to figure out what goes in these two. So, we multiply s squared times negative 48, and we get negative 48s squared. Now I want the factors of negative 48s squared that add up to positive 2s. Since 48 is negative, that means one of my factors has to be positive and one of my factors has to be negative, because that's how we get to a negative number. We multiply a negative by a positive. So we need to look at our factors. Some of them I can immediately write off, such as s and 48s. It doesn't matter if it's set up with positive s and negative 48, or if it's set up with negative s and positive 48. Either way, there's no way we're going to add up to positive 2. So those aren't going to work. We also have 3. We could divide by 3s and 16s. And again, we can say, okay, well, if we have negative 16 and positive 3, that would be negative 13. If we had positive 16 and negative 3, that would be positive 13. So that's not going to work because we need 2. So that doesn't work for us. We could have 4s and 12s. And if 12 was negative and 4 was positive, then we would have negative 12 plus 4 is negative 8. If 4 was negative and 12 was positive, that would be positive 8. So again, that doesn't work. Finally, we could have 6s and 8s. Now, if 8 is negative and 6 is positive, that would make negative 8 plus 6 is negative 2. So that doesn't work. But if 8 is positive and 6 is negative, negative 6 plus 8 is positive 2. That means that my factors need to be negative 6s and positive 8s. So I'm going to write those into my box. 8s and negative 6s. Again, doesn't matter which goes where, as long as they're both there. The greatest common factor of my first column, s squared and negative 6s, is s. The greatest common factor of my first row, s squared and 8s, is also s. I can make s become Negative 6s by multiplying it by negative 6. Negative 6 times s is negative 6s. I can make 8s become 8s by multiplying it by 8, because 8 times s is 8s. That means my factors are s plus 8 and s minus 6. Okay? I would like you to attempt to solve the two checkpoint problems. Remember, you'll need to draw your box. You'll need to fill in the top left and the bottom right, then find the factors that will add up to the middle number. Once you do that, bring the completed problems to class, and we'll see how we did.